All right, welcome. You know, when we hear robots in factories, our minds probably jump straight to some sci-fi movie scene, right? But the real story, it's actually way more precise, it's more widespread, and honestly, it's just incredible. So let's dive right into this revolution that's happening as we speak in automated assembly.
So have you ever really stopped to think about that? I mean, your phone, your car, maybe even the parts of the building you're in right now. How in the world do they get made with a level of quality that seems, well, almost impossible for human hands to do over and over again? The answer, as we're about to find out, is all about some seriously brilliant automation. So first up, why? Why is basically everyone, from car makers to aerospace engineers, scrambling to automate? Well, it all boils down to a set of really powerful promises. We're talking promises of speed, safety, and a kind of precision that we've just never seen before.
Okay, get ready for this number, because it's staggering. A 9 times improvement. In the super high-stakes world of aerospace, automated systems have slashed drilling position errors by a factor of 9. We're talking about going from an error of about 1.1 millimeters all the way down to just over 1/10 of a millimeter. And why does that matter? Well, it's huge. It means safer, more reliable aircraft because every single part fits together with near-perfect tolerance. It's not just a small step up, it's a massive leap forward.
Now this number, over 98%, that's not a grade on a test, that's the precision and recall rate for machine vision systems in electronics assembly. These robotic eyes are so unbelievably good. They can spot and place these tiny, tiny components with near-perfect accuracy. This basically wipes out the microscopic errors that could cause your favorite gadgets to fail.
And you know, automation isn't just about the products. It's also about protecting the people who make them. This number, 47%, that represents the maximum reduction in harmful shoulder movements for workers on the line. It's all thanks to these new adaptive workstations. This makes factories so much safer and cuts down on the risk of those long-term, painful injuries.
So when you pull it all together, it's pretty clear it's a win-win-win. You're getting faster production lines, you're getting precision that, let's be honest, humans just can't match consistently. The quality is the same every single time. And on top of all that, you get a safer place for people to work. That right there is the powerful promise of automation.
Okay, so we've seen the why. Now let's get into the how. Let's see how this stuff is actually being used across some industries you might not even expect. Think of this as a quick tour of the modern factory floor. And this table just shows how incredibly versatile this technology is. In the auto world, you've got machine vision guiding robots to put together complex gearboxes perfectly. In electronics, where you might have tons of different products on one line, you've got these advanced AI models that keep everything flexible but also super accurate. And get this, even on construction sites, optical projection is replacing old-school chalk lines to build faster and with fewer mistakes. Every industry has its own unique problem, and automation is delivering a custom-fit solution.
So we've said this a couple of times now, machine vision. What is it exactly? Well, the easiest way to think about it is like giving robots superhuman eyes. It's the whole technology that lets a machine see, inspect what it's doing, and analyze its own work, guiding it to do these really complex tasks with an absolutely incredible degree of accuracy.
Now here's a really fascinating idea. Sometimes the smartest way to automate isn't to build an even more complicated robot. It's to actually change the product itself to make it easier for a robot to put together. This is a huge shift in how we think about design. You're not just designing for the person who will use the product, but also for the robot that's going to build it.
But, and there's always a but, right? It's not as simple as just plugging in a robot and calling it a day. The path to full automation is actually full of some pretty big real-world challenges. So let's get into the reality check.
So on one hand, you've got this incredible promise of perfect, round-the-clock production. But the reality? Well, the reality is you're dealing with supply chain disruptions, you can't find enough skilled workers to manage these complex systems, and the costs to get started and maintain everything are just huge. The dream doesn't always match the day-to-day grind.
Let's break down these roadblocks a bit more. I mean, imagine you've built the perfect automated factory, but a single shipment of one tiny component gets delayed. Your whole hyper-efficient line can just grind to a halt. Then there's the people problem. You need folks who can actually run and fix these sophisticated systems, and there's a real talent shortage out there. And finally, the upfront cost of all the sensors and data infrastructure, the factory's nervous system, can be a massive hurdle to clear. These are the tough, practical problems that companies are wrestling with right now.
So, with all those hurdles, what's the answer? Is it a lost cause? Not at all. The good news is that the thinking around this is evolving. We're moving away from just automating simple tasks and toward building truly intelligent systems. This is the path forward.
This roadmap really shows how to tackle those challenges head-on. So instead of just waiting for a machine to break down, you use data from its sensors to predict failures before they even happen. To fix the skills gap, you use things like virtual and augmented reality to train people way faster and more effectively than ever before. And instead of having these rigid production lines, you use proven efficiency methods to make them super flexible, slashing the time it takes to switch from making one thing to another.
And one of the coolest tools for all of this is something called the digital twin. Probably the easiest way to get your head around it is to imagine a perfect one-to-one video game simulator for an entire factory. You can test out new layouts, predict where problems might pop up, and tweak everything in the virtual world before you spend a single dollar or stop production in the real one. It's an absolute game changer for planning and efficiency.
At the end of the day, the big takeaway here is that this isn't really about replacing humans. It's about augmenting what we can do. The technology is just advancing at this incredible pace, creating systems that feel less like simple tools and more like, well, collaborators. And that leaves all of us with a really important question to think about. As automation gets smarter and smarter, are we getting ready to work alongside it?